Hello everyone, this is Michael Spivak calculus. We're on problem set 3 of a basic property of numbers, which is chapter 1. So the number 1 for problem set 3 is A over B is equal to AC over BC if BC is not equal to 0. I think some of you may have confuse this with on how to solve this problem, because there's a fraction here and how to treat. We may not you may not know how to treat the denominator, but all this is just this. A times A over B is basically equal to A times B to the power of -1, meaning B is just 1 over B is just a multiplicative inverse of B. So let's start from here. A times B to the power of -1 is A times B to the power of -1 times 1, right? Because 1 is just identity, doesn't change the value, to the power of -1 times C -1. We know that C is not equal to 0, so there's a multiplicative inverse of this number. We will just denote this as a C to the power of -1. And then we can move this around by associativity. Well, this was here, the brackets were here originally, although this is hidden. The implicit rule here is that A times B -1 was in bracket, and we multiplied it by 1, and so 1 was just represented by C times C to the power of 1, so we can't put a bracket on them to represent this equation. And then we can move this associativity around, brackets around, to make this like the following. Well, first of all, let's apply the commutative law. C to the power of -1 times C. And then, using associativity, we can multiply the middle ones first, right? The way to go about from here to here is wouldn't be so intuitive for some. So let's do this after we prove this first. Then we can move this to here, AC times BC, which is equal to A times C over, well, I think this is gives us another challenges. A times C this is equal to B times C inverse. So let me prove this, right? Let's first prove this one. If A, B not equal to 0, then A to the power of -1, B to the power of -1 is equal to A times B -1. Okay, so this is another interesting aspect of inverses. Let's see if we can prove this. This is we're kind of sidetracked right now because of the thing that we haven't proved before, but kind of new to us. So I leave this here and then start proving with this one. Okay. So all we need to prove is that A to the power of -1 times B to the power of -1 is in fact equal to the multiplicative inverse of AB, right? So let's try this. A times B times AB. What is this equal to, right? If we can prove this is equal to 1, then that basically means that A times AB inverse is A inverse times B inverse. Okay, so move this around. We can do this. B is 1 times 1, which is again 1, right? Okay, so we proved it. Nice. So this is true. We can move on from here to here. So then that's basically AC over BC. Done. So how did it go about from here to here? Let's do that. A, B, C, D is equal to well, it's basically equal to A times B well, we can do this now because of associativity. What is really associativity? Let's go back to definition. Just stick to the symbols that they gave us. Let's see. Associative law. Okay, ABC is equal to ABC. Same with the... Okay, got it. So we have A times B times C times D, right? This is also equal to A times B times D, right? Where D is equal to C times D. That means that we can move this to say this is equal to A times B times D, right? Then what is this equal to? A times B times C times D, right? Then what is this equal to? A times B times C times D, right? What is this equal to? A times C, big C times D, right? And what is this equal to? A times C times D, right? So we can effectively say that since these are equal, A times B times C times D, this is also equal, right? So that's how we got from here to here. Alright, so moving on, let's go to problem number 2. Since that sounds like a little bit more work than the number 1, because it's just a lot of abbreviations of things that are down here, which is the fraction. Fraction is just when denominator is just a multiplicative inverse of some number. So one way to confuse things. And then there are many associativity and commutative law that's skipped, that need to be skipped to prove this fast. But why hurry? Let's do one by one. Alright, so A plus B plus A over B plus C over D is equal to what? a to the power of a times b minus 1, c times d minus 1. So what is this equal to? We can use these two well, we can make this side multiply 1 but with d terms, d minus 1 plus c times d minus 1 with b terms, sort of like trying to make the common denominator for both. Then we have AD over BD and plus this is CB over BD, right? After moving things around with commutative law and also the fact that we're using this one, right? Can be ignored. Cannot be ignored is one, okay? And then this is basically, what does this mean? Right? We have common denominator. Common denominator means we can pull this out, right? 1 over BD on both sides by multiplicative law. A distributive law, right? Distributive law. And then that is what it is. Same thing. So we proved this. And also the reason we can take this, multiply these terms on both sides is because b and d are not equal to 0. Alright, so these were the proof. And we'll get to, well, what? Number 7 here. We'll get to number 4. I believe number 4 is over here. Oh, wait a second. There's some more. Alright, so we'll get to 3rd, 4th, 5th, and 6th on the next next video. Stay tuned. See you next time.